Start.
Good morning, all of you. So my topic of presentation is mixed design of high strength concrete. So I think all of you know about normal concrete, standard concrete. So something new which I am discussing today in the class about high strength concrete. So before going to the contents, just I want to tell you that what are the benefits of high strength concrete. Nowadays, from this classroom we can understand, suppose this, if we use high strength concrete in this column, their size will be reduced. So one very big advantage is, and for heavy loadings like bridges, structures, or there are so many places where loads are coming in very high magnitude. In that places also high strength concrete is very useful. So after attending this session, you will know about what is high strength concrete, and you will also have idea about the updated Indian Standard Code that is useful, IS 10262 2019. Earlier it was IS 10262 2009. So this is the updated version we will learn in this class. And another thing I will also discuss with you about the basic steps of mixed design also. So I am assuming that all of you have some idea about the concrete materials, tube test of concrete, IS 456 2000, IS 1026 2009. And you have some idea about the virtual lab also, because nowadays this is very common in every engineering college. Students are learning using these labs. So what is high strength concrete? What is high strength concrete? So as per this code, if the grade of concrete is M65 or above, then we call the concrete is high strength concrete. So concrete is simply, if I tell the concrete is a combination of cement, sand, fine aggregate, coarse aggregate, water. So what we are adding in that combination, that concrete is becoming high strength concrete. So for high strength concrete, what we are using, the cementitious material. Earlier the cementitious material was only cement. But nowadays, cementitious materials, there are so many materials are ongoing in research area, like silica fume, we are using silica fumes that enhance the strength of the concrete. Then GGBS, ground granulated blast furnace slag. So there are so many cementitious materials nowadays are coming, and many researchers are working on these topics, so that if we construct the bridges, then the span of the bridge between two columns, the span of the bridge can be increased if we use high strength concrete. And we know that the compressive strength of the concrete is inversely proportional to the water cement ratio. So if we increase water cement ratio, its compressive strength will decrease. So for high strength, obviously the lower water cement ratio is recommended. So we have, whatever we are telling is from this code only. So what is new in this code? All of we should know that, because in civil engineering, whatever we do as per the code guidelines. Without approximate more than 2000 codes are available in civil engineering, and for each particular work we use particular code in particular situations. So in this code we have 5 sections. In this code we will get idea about ordinary standard grade of concrete, high strength grade of concrete, then self-compacting concrete. Self-compacting concrete means there is no vibration due to this self weight, no compaction required, no vibration required. Mass concrete. So in this course, these 5 sections have been included. So some table I have taken from this course that I want to discuss with you. That there is earlier how we were calculating the characteristic target compressive strength. So earlier we were using F bar Ck equal to Fck plus 1.65 sigma. Fck is we calculate the average compressive strength of the concrete after 28 days, and sigma is the standard deviation. So from this table we can get the value of assumed standard deviation. Suppose we are high strength concrete we are discussing, so maybe suppose M70. So we will get the value of sigma as 6. So 6 will be the values, and Fck means suppose we are M70 means value of Fck will be 70. Then in this way we can calculate the target compressive strength. But in this code there is another formula have been included for target compressive strength. F bar Ck equal to Fck plus X. So this new factor have been included. So for value of X we calculate from this table, table 1, that M65 and above we will get the, we will take 8 value of X. So for this we can say 70 plus 8, it will be 78. So out of these two, whichever will be the maximum value will be the target compressive strength. क्योंकि हम लोग देखते हैं कि कंस्ट्रक्शन में क्या होता है कि हम लोग जो डिजाइन इंजीनियर जो होते हैं वो रिकमेंड करते हैं कि इस ग्रेड के लिए आपको ये स्लैब बनाना है, ये मिक्स डिजाइन करना है, लेकिन कॉन्ट्रैक्टर जो होते हैं उसमें काफ़ी सारा प्रॉब्लम्स होता है। तो एक्चुअल में इसीलिए जो कोड जो है पहले से एडवांस चलता है, क्योंकि M70 चाहिए तो हम लोग M80 का प्लानिंग करेंगे कि ये इसके अनुसार हमको मटेरियल्स को मिलाना। सो दिस इज वेरी यूजफुल कोड। So we can understand from next slide. So these are the tables. We can understand the various parameters useful in the design of mixed design of high strength concrete. We take the water content values based on the aggregate size, then volume of coarse aggregate per unit volume, total aggregate we can calculate using this table. And this is also recommended value of high strength concrete made with HRWRA, high range water reducers admixture. So we can see the target compressive strength based on this value. Suppose we have 85 is our target compressive strength. So based on this value and the size of aggregate, we can take the values of water cementitious ratio. So these are the admixtures. We already discussed about silica fume. So how much silica fume we can use in high strength concrete? IS code has already recommended 5 to 10%. So these are the values. So these are the mixed design steps. Already in this code, in the last, they have given the one examples of every types of concrete mixed design calculation. So from section appendix D of IS 10262/2019, we can understand the design steps of high strength concrete. So these are the design steps. So we will calculate the water cementitious ratio, then selection of water content, calculation of cement content. All we follow step by steps with the guidance of this code. So mixed design calculation and mixed proportion is for trial number 1, means trial numbers. Suppose in trial 1 we get the amount of cement in kg this much, then cement, sand, fine aggregate, coarse aggregate, then cementitious, another cementitious material like fly ash this much. So we will prepare one sample, means 3 cubes we will prepare, and we will test in the concrete lab using the CTM machine, compressing testing machine. And suppose we will not we are not getting that target strength as per the codes, so we will go for another try. So at least code recommended 2 more tries, so at least 3 trials for each mix design is recommended. So conclusion, this is after this session you have some idea about high strength concrete, and we can understand that high strength concrete is very helpful in reducing the dead load of the structure. So dead load means permanent load of the slab. Permanent load is called dead load, like columns, beams, slabs, foundation. These are permanent structure in every civil engineering structure. So these are comes under dead loads. So if we use high strength concrete, size will be reduced, and automatically we can say that the dead load will be reduced. So another thing that I want to add in my class, that the ultra high performance concrete is also a type of high strength concrete, and it is a good area of research. And about this concrete code, there is no any guidelines about this particular concrete, but still in industry somewhere it is useful. So we can learn about the ultra high performance concrete. I want to share something about ultra high performance concrete also. That suppose this is a slab. Now what is happening? We are using steel bars CUG, but this in concrete no bars is required. Means we are adding some fiber, steel fibers or other types of fibers, and that will take care of the compressive strength as well as the tensile strength. So concrete is a vast area of research. So there are some questions for you. If you understand, you have understood, then you can answer. So what are the benefits of high strength concrete? Anyone please answer.
Section size reduce.
Very good.
Dead load reduce. Ultimately cost reduce.
Cost also because cost is a very heavy part of research, because we have to check the cost part also. And our second question, what are the steps of this design? Anyone?
Given a table.
As per IS code, we can do this. So, what are the IS code useful in mixed design of high strength concrete? Very good answer. What is ultra high performance concrete? Anyone please? This is very important. It may be your house will be built with this material in future, because this will be totally means industry is going to change if it comes into implementation. Okay, thank you. Good.